So hello everyone. In this discussion we are going to talk about three types of partial differential equations. One is heat equation, the other one is Laplace equation, and the third one is wave equation. We are going to discuss about three types of partial differential equation. One, because it is very important when it comes to industry. Because in industry, maybe we are going to talk about turbines, or we are going to talk about heat transfers, or we are going to talk about wave motions. We are going to talk about partial, but in what manner, in what type? So that is what we are going to discuss here. One is heat equation, Laplace equation, wave equation. So you can see here, heat equation is a partial differential equation with second order number. We have a dou u by dou t, and which is equated with dou square u by dou x square. Here, why we call as partial differential? Because two variables are involved. T variable is involved and also x variable is involved. Two independent variables are involved. That's why we are calling it as partial differential equation. So what it does? It describes how temperature evolves over time in a medium with thermal diffusivity. Okay, that is this alpha. No, it is a kind of some idea where we are going more technical. Okay, so we now understand the diffusivity of the thermal conductivity sources. So again here, heat is involved in this. So heat equation. When we talk about type of PDE, you know heat equations are parabolic equations. Heat equations are parabolic. Heat equations are parabolic equation in nature. So heat equations are parabolic equations in nature. And again, suppose if we are going to talk about the other type of partial differential equation, that is Laplace equation. Again, we can call it as continuity equation, or else we can call it as Laplace, because Laplace was the person who was talking more on this. So Laplace equation, which is here they are talking about the two-dimensional, because it is dou square u by dou x square plus dou square u by dou y square equal to 0. Again, you can convert to three-dimensional also. You can add one more term there, dou square u by dou z square even if required. If the situation allows you to add it. Okay. So what it does, Laplace equation, it describes steady state distributions, no change over time, steady state distribution, that is continuity. I'm talking about continuity equation. So steady state. Suppose if we talk about heat and mass transfer, suppose for example fluid flow can be of different scenarios. It can be streamlined, it can be turbulent. Okay, it can be of a different type. So we are now to understand how the status is. So here Laplace equation is again a partial differential equation, because the reason is it involves more than one independent variable. Here use the function, so use the function of x comma y. Here use the function of x comma y for Laplace equation. When you talk about heat equation is like use the function of x comma t, because it is dependent on distance, displacement and time. Here this depends on two axes, x and y axis. Again, Laplace equation is again a type of partial differential equation, because you see Laplace equations are elliptic in nature. You can see the structures. Laplace equations are elliptic in nature. So Laplace equations are elliptic in nature. Again, we have the discriminant ideas where we can understand by applying the concept of discriminant ideas to understand what type of equation it is. Okay, that is fine. So this is the second type, and when you talk about the third type, that is wave equation. Where we see wave equations. Wave equations are connected with again two variables, because you can see dou u square u by dou t square is equal to c square dou square u by dou x square. Here also u is the function which is connected with two variables, which is x and t. Okay, which is x and t. So partial differential equation again. What it is? Wave equations are again partial differential equation. And what it does? It describes how a wave propagates through space at some speed c, with some speed c. So again, this is a very important approach when we talk about wave equation, or wherever this is wave propagation areas. Okay, in wind turbines and all, when we talk about wind turbines and all, in industry level, we use this in our departments or for various derivations and all, we come across wave equations. So again, wave equation is also a type of partial differential equation. Wave equations are hyperbolic in nature. Wave equations are hyperbolic in nature. hyperbolic in nature. So this is what I was trying to discuss today. Thank you.